It does not matter how beautiful theory is. It does not matter how smart you are. If it is not agree with experiment, it is wrong. Hello friends, I am Senapati, your physics teacher from Aryabhatta Career Academy. Today's topic is units and measurements. You can say it is the first topic of plus 2 science, or some places we say it as intermediate. So I said that how smart you are, how beautiful your theory may be, if it does not agree with the experiment, it is wrong. So I think physics is the place, the subject, the science which is full of experiment. I think there is no better place than physics, where we do more experiment like the chemistry also. So today's topic is units and measurements. You know that physics is an exact science which gives information about the nature and natural phenomena, and it expresses the different natural phenomena in terms of a relationship among the different quantities involved in it, and so far as the relationship is exactness concerned, there should be a exact measurement. For exact measurement, we need the instrument which is exact. So in this topic, I shall explain regarding the measurement, how to measure, how to express the measurement of different physical quantities. So before measurement, at first we have to know physical quantities. So what are physical quantities? Physical quantities. Okay, children? So what is physical quantities? The quantities which can be measured, the quantities which can be measured, we say physical quantities. For example, we can measure the length, we can measure the time, we can measure the speed, we can measure the velocity, we can measure the acceleration, we can measure the brightness of the light. All these are called the physical quantities. That means the quantities in which we can express, we can prove the laws of physics, that are called the physical quantities. So the quantities which can be measured or by which we can prove the physical quantities. I said length, mass, time, speed, velocity, acceleration, brightness, temperature, all these things can be measured. These are called the physical quantities. Again, these physical quantities are classified into two types. One is the fundamental quantities. What are the fundamental quantities? The physical quantities. The physical quantities which do not depend upon other quantities. They are called the fundamental quantities. There are 7 fundamental quantities there. To explain the various laws of physics, what are the 7 fundamental quantities are there? One is the length, mass, time, temperature, length, mass, time, temperature, luminous intensity, current, length, mass, time, temperature, luminous intensity, current. These are the 7 fundamental quantities through which we can prove all the laws of physics. Next is the derived quantities. What is derived quantities? The physical quantities which depend upon others, or I can say that the physical quantities which can be expressed in terms of fundamental quantities. The physical quantities which can be expressed in terms of fundamental quantities are called derived quantities. For example, speed is a derived quantity because it depends upon distance and time. Distance means length. I can say that acceleration it is change in velocity per time. So this is also a derived quantity. Area, length into breadth into height, it is also a derived quantity. Force, mass into acceleration, this is also a derived quantity. So anything which can be expressed in terms of fundamental quantities, or I can say that the physical quantities which depend upon others, they are called derived quantities. So this is about the physical quantities. Two types I said. One is the fundamental quantity, second one is the derived quantity. Next point is, what is the need for measurement? The question comes, what is measurement? Because the topic is units and measurement. We should know what is unit, what is the measurement. So measurement means the comparison of a physical quantity with a known standard quantity of same kind. Listen carefully. So, for example, I want to measure the length of this board. What I will do? I shall compare its length with a certain unit. For example, feet. With me, feet scale is there. I shall compare the size of the length or length of the board with that feet scale. So measurement is nothing but a comparison of a physical quantity with a known standard quantity of the same kind, that is called the measurement. And so far as the measure of a physical quantity is concerned, measure of a physical quantity is the product of a measure of a physical quantity is equal to numerical value into size of unit. Today pen is giving some trouble. See here. So numerical value into unit. Suppose this is the physical quantity, n is the numerical value, u is the unit. So I can say that q is equal to n into u. Here n stands for numerical value, u stands for size of unit or unit, and q stands for physical quantity. So measure of a physical quantity I have written, it is the product of a numerical value and unit. These two are inversely proportional. N is inversely proportional to u. That means, you see that, for example, I am writing a physical quantity 20 centimeter. Here 20 means numerical value. Numerical value. Centimeter means unit, both are inversely proportional. What inversely proportional? That means if the unit is larger, if the numerical value is larger, unit will be the smaller. If the unit will be larger, numerical value will be smaller. For example, I have written 20 centimeter. I can write 0.2 meter. What happened here? Here the unity became larger, numerical value became smaller. Here the unit became smaller, so numerical value became larger. So numerical value is inversely proportional to size of the unit. For example, N1, N2 are the numerical values correspond to sizes U1 and U2. So I can say that N1 U1 that is also equal to N2 U2, which is equal to physical quantity. So the physical quantity is the product of a numerical value and a unit. Next one. This is about the quantities. Next, I would like to say about the units. So what is that unit? Unit is nothing but the standard known quantity. The standard known quantity what we are using to measure the size of an object or to measure a quantity. That standard known quantity is the unit. Standard known quantity which is used to compare the size of an object, we say that is the unit. Okay, units like physical quantities, there are two types of units are there. What are the two types of units? One is the fundamental units. Fundamental units. What is fundamental units? The units of fundamental quantities. The units of fundamental quantities are called fundamental units. Derived units. Derived units. The units of derived quantities are called derived units. For example, I am writing here meter. Meter is the unit of length. Length is a fundamental quantity. So I can say that meter is a fundamental unit. I am using kilogram. It is the unit of mass, which is a fundamental quantity. So kilogram is a fundamental unit. I am using second, which is the unit of time. Time is a fundamental quantity. So I can say this is a fundamental unit. Units of derived quantities are called derived units. For example, I am using speed. The speed unit is, I can write meter per second. I can write like this also. Okay. So this is the unit of a derived quantity. So I can say it is a derived unit. Unit of work. Work is the product of a force and displacement. I can say it is Newton meter. So work is a derived quantity. Newton meter is a derived unit. So many more things we will discuss later. Just I said the meaning of fundamental quantities and derived quantities. Okay. Now let us move towards the system of units. Today's topic is just an introduction class to the units and measurements. Just I am discussing with you the fundamental some concepts related with the topics which is very essential, what we cannot avoid. Next one, system of units. System of units. System of units means a set of units what we can use to express all these physical quantities. So I can say that a set of units, which are used to express all the physical quantities are called system of units. There are three different systems of units are there. What are the three different systems? One is the Cgs system. In fact, it is a faint system. In this system, length, mass, time are expressed as centimeter, gram, second. This is a Cgs system, faint system. Second one is the APS system, foot pound second. In this system, length is expressed as foot, mass is expressed as pound, time is expressed as second. This APS system, in fact, it is a British system. Third and most important system what we use frequently, that is MK system. This is also faint system. In this system, length is meter, mass is kilogram, time is second. So I'm thinking it is not appearing. Length is meter, mass is kilogram, time in second in MK system. Except these systems, the system what we have been using internationally, that is the SI system. We say international system or standard of international. This is international system, or we say international standard. In this system, all these 7 fundamental quantities what I said, it is possible to express with these international systems. Let us see. So in SI system, length, mass, temperature, current, luminous, intensity, and one more thing I forgot to say, that is amount of substance. This is also one of the fundamental quantities. Out of 7 fundamental quantities, this is also one of the fundamental quantity. In the beginning I might have not mentioned. Okay, I mentioned here. So in SI system, these are the physical quantities. These are the physical quantities, and the unit length we use meter. Shortly we can write M. Mass, kilogram, we say kg. Time, second, we say s. So in NK system also length, mass, time, same thing, meter, kilogram, second. Temperature in SI system, Kelvin, right? Shortly K. Current, it is the ampere, we write A. Luminous intensity means brightness of the light. Candela, we use symbol CD shortly. Amount of substance, that is mole. Okay. So these are the 7 fundamental quantities what we need to understand the laws of physics. Except that 2 more supplementary quantities are there. What are that? One is the plane angle, one is the solid angle. Supplementary quantities. One is the plane angle. We express with radian. Okay. Another one is solid angle. Radian, shortly I can say RAD. Solid angle. We use the term steradian. Shortly we say SR. Here radian. Radian means, suppose this is the circle. The angle made at the center of the circle by an arc which is equal to radius of the circle, that is called the radian. Radian means the angle made at the center of a circle by an arc of length equal to radius of the circle. Okay, so radian we can say this is L by R. L is the length of the arc, R is the radius. So if both are equal, how much length that much R, then it will be equal to 1 radian. So 1 radian is the angle subtended by an arc of length equal to radius of the circle. Similarly, the steradian, this is the unit of a solid angle. Solid angle means you think this is like a sphere. We are taking a part of the sphere or surface. This is the center. How much angle it is making, that is equal to steradian. So I can say that angle subtended at the center of a sphere. The angle subtended at the center of a sphere with the surface area equal to surface area of a square of side equal to radius of the sphere. So, steradian, we use the symbol, this is for steradian, is equal to surface area divided by square of the radius. Okay. So, this is about the system of units. So, this was the introduction class. I hope that you might have understood this concept. I am expecting that you will not forget to share this video with your friends. Until the next video, bye.